Here we have a question based on the properties of similar triangles. How do we know that we are dealing with similar triangles? Look at the statement that we have to prove. It involves ratios of sides of triangles. Where have we seen that? In similar triangles. So that is how we are going to prove this result. Now let us start constructing the figure from scratch. What do you have? First, a line segment DE, then another line segment OB, which is perpendicular and bisects DE. So whether you need the result or not, you have to remember one thing, which is DB is equal to BE, and that is equal to half of DE. So whether you use this result or not, remember that such a thing exists. So if ever in the course of solving this question you get stuck anywhere with any one of these quantities, remember to put the other two in its place. So now let us continue. What else is given? Another line FA, such that FA is perpendicular to OB. Now we have two right angles. Can we get two right triangles out of this? Why not join all of this? Then what do you have? You get two right triangles. One right triangle OFA, a small triangle. Another one, a big triangle ODB. This whole thing. Can we prove that they are similar? In the small triangle, the right angle is at A. In the big triangle, the right angle is at B. Then what? Both of them have the common side O there. So you just need to get two equal angles. Then by AA similarity rule, just put the add the third vertex also, like this. So these two are similar by AA similarity. Now the minute you see two similar triangles, there should be four equations in your mind. What is that? First two angles equal, second two angles equal, third two angles equal, and the ratio of the first two sides is equal to the second two sides. That's why you have to be very careful about the order, okay? And then the third two sides are equal. Their ratios of these sides are equal. So you see, we have already got an OA and a OB. So we are already there. We just need to get a OC. Shall we continue with the construction? There is still one more construction left. Then what do you have to do? Join FE. Then what do you see? It meets AB at the point C. Now, how do you include OC? Now, next consider the triangles AFC and CBE. Where are we going with this? We need ratios which connects OA and OB and an OC. But if you are looking to get a triangle with the side OC, so the triangle you will be going for will be what? FOC. But don't go for that. Instead, just limit it to this small triangle AFC. Why is that? Why are we limiting it to that small triangle? Because you will notice that it is again a right triangle. So you already have one angle equal. A right angle here, a right angle here. You already have one angle equal. You just need another equal angle. And where will you get it? Here. Vertically opposite angles. There, you see, again using AA you can prove that these two are similar. Now how will you write the similarity of these two triangles? In this triangle AFC, the right angle is here at A, here the right angle is at B. So wherever you see A, you write B. Again here a C, here a C, vertically opposite angles. So where you see C here, the same place, put C here. And what is the only thing that is missing? The only vertex that is missing? put that. So this is how your similarity looks. It is not CBE, it is actually BEC. And the minute you see two similar triangles, what should you understand? The first two angles equal, the second two angles equal, and the third two angles equal. And how does the ratio work? The first two sides here, and the second two sides, and the third two sides there. Now what do you see? You see two different ratios. For example, I have two different ratios like this. If I prove randomly, if I can prove B and Y are equal, what will that mean? All of these 6 quantities are equal to one another. Can we get such a thing here? Can you see any two ratios in these which are equal? See, an FA here and an AF here, but then here we have DB and here we have DE. But then what did we start with? It is perpendicular and it bisects, which means what? This DB and this BE are both same, which means all of these 6 quantities are equal to one another. But we don't have to break our head with all of them. We will just take the ones we need. What are the ones we need? We need an OA, we need a OB, and then from here, how can you get an OC? Which ratio will you take so that it includes a OC? What about FC? Do you think FC will include an OC? No. Then which one will you take? AC. Here AC. What is AC? It is OC minus OA. And what about BC? It is OB minus OC. There. This is the relation that we are looking for. Let us cross multiply, then what will we get? Now, how will we proceed from this step? What do you see here? There are 3 quantities which we need to prove. A relation between 3 quantities, which is OA, OB and OC. And if you look at this equation that we have here, what do you notice? In each of the term, there is one thing missing. Here, OC is missing. Here, OB is missing. In each of the terms, one of these quantities is missing. So, what do? Why don't we divide everything by OA into OB into OC? Then what will be the first term? It will be 1 by OC. What will be the second term? It will be 1 by OB. What about this term? It will be 1 by OA. And this term, divide throughout by this. So here, right? So why don't we take OC here? So it is OC plus OC. On transposing the terms, you get such an equation. This is equal to what? It is 2 by OC. So this is the equation. This is the result that you were looking for. That is all for today. Take care. Assalamu alaikum.